All right, let's get right to it. The goal today is to design a 6-bar leg with a translating link. I have already attached the results of our construction of a coupler curve. Here is an interesting coupler curve that a couple of my students found. So I'm going to use that as the basis of our design. I cut I took a screenshot of the image, put it on the background, and now I'm going to reproduce it. And I'm going to do something slightly different. I'm going to make the base rotatable so that I can position the coupler curve downwards like it's the foot of a walking machine. So let's get right to that. So this will be the fixed pivot for the moving crank. Let's go ahead and measure that. So we have to add points to this drawing in order to make it, to do this. I'm going to make these red so that they stand out. So there's one here, here, and here. And we're going to need this coupler point as well that generates the coupler curve. All right, so here's the input crank. Put that here. Color it yellow. Now what I'm going to do is I'm going to measure the base link, and I'm going to set it up so that I can rotate it. So let's define an angle, and this angle will be used to position the base link. Intersect this circle here. Now measure our angle of orientation for the entire linkage, which we'll set at alpha. This is now going to be the base of the linkage. Give it a sort of solid gray color, make it nice and thick. And this is going to allow me to reorient the linkage and place the foot downwards. So let's position it in roughly the same position that we have here. Now we'll introduce the crank. So we'll take the intersection of this and this, measure this angle. Oh, I'm sorry, I got to create the slider first. So I need a slider for the input crank. This is going to be the angle gamma. Let's now measure it, or specify its angle. So we'll specify it as gamma. All right, this will make this segment and give it the color green for our input link. Now we'll complete the 4-bar by measuring the coupler and the follower links. The intersection here will be our coupler. Let's color it blue and color the follower red. The advantage of this construction is that I can now, that's not right. I put the coupler circle in the wrong location, so let's fix that. All right, so here, and then we'll put it here. This is now the correct intersection. Now we'll put the coupler from here to here, blue, from here to here, make it red. Now, when we rotate the coupler, that's fine. And now when we rotate the base link, it takes the entire linkage with it. And that's the goal. All right, so let's hide this. Now let's add the coupler link. We'll do that by measuring these angles. So we need this angle here, which is going to be epsilon. Then we need this angle here, which is going to be zeta. So we'll keep track of that as we go along. We'll use those more than once. So let's now duplicate that coupler triangle. This will be epsilon. All right, and then this will be zeta. Draw these lines to get their intersection. One. And here's the other. Make sure they're lined up properly. And get the intersection to define the coupler. We'll introduce the polygon. Make this polygon blue to match our coupler. Let's start hiding some of this. Well, first, before we do that, let's check and see the trajectory of our coupler curve. Make sure it matches. So here is our coupler point. Here is our crank, and there it is. Looks similar, slightly different. Oh, because I'm not quite sure why. Maybe I measured the points. Maybe I didn't measure the points as accurately as I should have. Could be that these points need to be adjusted slightly. Oh, that's not good. That looks a little better. Maybe these points need to be. All right, we'll go with this. Let's hide the stuff we don't need. I'll get rid of these, hide these points. Now the goal here is to add another set of links that will move in parallel so that we can create a leg. So we have this foot. We can also use this angle to reposition the linkage so that the foot is in the downwards direction. All right, so now the work begins. So we have a couple things we have to do. First thing is to copy this coupler triangle onto the input link, and we're going to use those same angles. We're going to copy epsilon here. We get that line. And then we're going to copy zeta on the other side. And we now have a small version of the coupler triangle sitting on the, let's zoom in just a little bit. Small version of the coupler triangle sitting on the input crank. We'll color that green. We have to hide these other points so that they don't confuse us. hide the lines as well. And that's going to be, now we need 2 more links, and the way we're going to get these links is going to be something new. So we're going to use the, under this menu item, we're going to use the rotate around a point and the dilate from a point operations. It's going to happen like this. Let's zoom out just a little bit. Now we're going to create this polygon. Make it light green. And we're going to rotate this polygon around this point, the moving pivot, by the angle that we've already measured, which is epsilon. So we're going to select this, rotate around a point, select the polygon, we're going to rotate around this point, and now we have to tell it what angle. The angle we're going to use is epsilon. And that's going to rotate this quadrilateral around this point and line it up. Now we have a little bit more work to do. We have to measure these distances. I need the distance from this point to this point, which is EH, and I now need the distance from this point to this point, which is EF prime. Those are listed over on the side here. So it's distance EH and distance EF prime that we're going to be using. And we're going to take the ratio of those in order to expand our polygon. All right, so the polygon that we're going to expand is this one. Oops, excuse me. Let's see if we get into the right selection, the correct selection. Let me move this over just a little bit so that we can see what we're doing. All right, don't need this, but we do need the dilation tool. Okay, so we are going to dilate this polygon around this point by the ratio distance EH divided by distance EF prime. And it expands it, and it gets us these 2 lines, which are the ones we need. Let's denote those with segments. I need this segment. I'm going to give that magenta. And I need this segment. I call that, actually I want that one to be magenta, and I want the other one to be cyan. So we'll make, whoops. This segment to be cyan. See what happens. Let's getting a combination of colors. Well, the next step is to generate parallel lines. We want a parallel line to this side that goes through here, a parallel line to this side that goes through here. And these are actually the segments we want. All right, so we are going to go back over to the other side, and we're going to construct these segments. So we want this distance from here to here will go on the moving point, and then this distance from, oops, sorry, wrong one. This distance, let's see, we're going to have to zoom in to get it. Let's zoom in just a little bit. I'm going to actually hide that point. That'll make it easier. Let's just hide this point. All right. So I need this distance from here to here, and I'm going to put it on my rotating coupler link. Intersection point is the point I'm looking for. Get this intersected with this, and I now have a segment that goes from here to here, a segment that goes from here up to here. We'll make this one cyan. We'll hide the circles so that we can see what's going on. And now let's animate the linkage. Let's select this. Object animation. Now what's important to notice is that this link that we've just constructed does not rotate. It moves in a pure rectilinear movement. Let's adjust this so it's increasing. Slider, increasing. All right, so here we go. It's just going to continue around. Now that link is undergoing pure translation. And what that means, is that this point, if I look at its locus, is exactly the same as the coupler curve. Let's try it again. The locus of this point is exactly the same as the coupler curve. And in fact, if we find any point, if we can construct any point connected to this, and it will have the same properties. So let me create a little length here. And now that'll allow me to adjust it. We'll put this here, intersect the two, and this creates the foot. So I now have a little walking foot. And now let's rotate it around so that it's actually pointed to the ground. And we'll trace its trajectory. Rotate it slightly back. Maybe I should actually, let's see, and we'll see how it looks. There is our leg. I can stretch it out a little bit. That's our leg with a translating link. Let me clean it up. So let's see, we'll get rid of some of these. And there we have it. Let's run it again. And there's our leg mechanism. This link undergoes pure translation, so whatever the coupler curve was at this point, we repeat it here, and it'll be repeated here. Thank you, and I hope you found this useful.